Thank you very much, and hi from my side as well. So it's a real honor to be here and talk to you about OAuth. Just quick introduction about me. So I'm both an identity practitioner as well as a standardization guy. So I've been working in the identity space for 13 years now. First in the consumer identity team at Deutsche Telekom in Germany, where we used OAuth 2 to protect our APIs for entertainment services, communication services, and cloud services. And now, since 2017, I'm the CTO of Yes.com. We are an open banking scheme. We allow or we enable financial institutions to become identity provider and to leverage their internal capabilities in terms of identity data, electronic signing, payments, and so on via APIs. And again, in that context, we heavily use OAuth 2 for protecting access to these APIs and OpenID Connect. And on the standardization front, I joined the OAuth community and the wider identity standardization community back in early 2010, when the work on OAuth 2.0 just had begun. Around that time, my first contribution to the development of OAuth was the OAuth security thread model and consideration. I was the editor of RC 68910, which became the foundation of the core specs security considerations. I've been contributing to other specs since then, and I also currently work on a couple of different specifications in the OAuth space, most notably, for example, the new OAuth security guidelines and OAuth 2.1. Let's start with the OAuth design principles. The basic principle of OAuth is that an API is being protected and authorization towards an API is implemented using so-called access tokens. An access token is a temporary credential that is issued by a authorization server, which is a trustworthy third party. And that way, OAuth 2 decouples the service invocation and the authorization of an API access from the actual authentication and authorization of a user, which has a lot of advantages. For example, from the software architecture perspective, it allows to build APIs which are agnostic to channels, because mostly, in most cases, if you want to authenticate and authorize access, especially on behalf of users, you will have the need for different kinds of flows. So there's a big difference in authenticating on a smartphone from, for example, authenticating and authorizing on a TV set, for example. And it might be also a difference if there is a batch job that accesses your services from a user-based service. So OAuth nicely encapsulates those differences in the different grant types that the client uses to obtain access tokens from the authorization server. And on the other hand, the API is completely unaware of this fact. So you do not need to implement different APIs for different channels. And moreover, since there is a clear split between the getting the access token and using the access token, the application is also free to orchestrate. So it can, at will, use the different access tokens for different APIs as it wants. From a security perspective, there are also several nice properties. So for example, the authorization server as a central service handles all the user credentials, which also means that neither the API nor the client needs to handle user credentials and also user consent. And this, in turn, results in a reduced attack surface. And which is becoming even more important these days is, since the authorization server controls the user experience during the authentication and authorization process, it can use all kinds of origin-bound credentials. For example, FIDO keys. And it's also quite easy to extend your deployment with a third-party login, even in API scenarios. So you can see a lot of advantages from a security perspective, but what about the user? In the end, through this split, a user can log in once, authorize access to the API, and then the client on behalf of the user can use the access token several times across different APIs without the need for additional or further authentication. And this, in the end, is kind of a single sign-on experience across APIs. Let's come to the essential parts from my perspective. Let's first take a look onto the OAuth 2 universe. OAuth, in the beginning, was quite simple. There was one core draft that defines how to get access tokens, and another draft, or an RFC, that defines how to use those access tokens. And as a complementary draft, there is the OAuth threat model and security considerations. Those drafts were published back in 2012. And then a lot of more RFCs were published, all in the OAuth universe, that introduce new mechanisms, for example, to new device classes, different use cases, but also so-called best current practice that explain how OAuth shall be used in different scenarios. And I agree, and I admit, this universe sometimes is much too complex for developers. And that was one of the reasons why Jim asked me to give this talk and to explain to this audience what the essential parts of OAuth are from my perspective. And I happily will do so. Please note, in the end, all those RFCs are important for one or the other use case. My perspective is that of a practitioner that has implemented consumer-facing services. So I always implemented consumer-facing services and APIs, and those are the essential parts that I think shall play a role in your consideration. First of all, the authorization code grant is the foundation of everything, because it allows you to implement the authorization process for any kind of application in a rather simple and secure way. Let's quickly talk through the process. So let's assume the user interacts with an application and wants to access services or resources that it has with another service provider. So for example, that's a calendar service, and the user wants to, in this calendar service, also accesses the contacts that it maintains with a different service. So the flow basically is rather simple. The client redirects the user agent to the AS and hands over the user control of the user experience to the AS. The AS authenticates the user and, if required, also asks the user for consent for the access that the client just requested. If the user consents, the user agent is sent back to the client with a parameter called the code, the authorization code. This is a temporary one-time use credential that the client then, in a backend interaction, exchanges for an access token. And it then uses that access token to invoke one or more APIs. The flow, as you see it on this slide, is already aligned with the new security guidelines and the upcoming OAuth 2.1 specification. So let's go through the details. So in my experience, the authorization code is the most versatile and secure way to integrate your applications for user-facing services with APIs. It's versatile because you can implement all application types with this flow, and I have done so in the past. So web application, I think no doubt, because OAuth was developed with web applications in mind. But even also native applications, smartphone applications, can be implemented with the authorization code. If you do not like the web experience and want to come up with an even better and optimized user experience, you can also implement a native front end for your authorization server, and based on the same underlying protocol, the redirect, implement a so-called app-to-app redirect. This has been done, for example, in the open banking space in the last years in the UK, and the statistics suggest that this results in a much better conversion. But you can also use the authorization code for your JavaScript application, your SPA. All it requires is you need to activate CORS. And you can combine authorization codes on those app types also with all client types that OAuth supports. So most people think that, for example, native apps and SPAs must be public clients, but that's not true. So you can also build a confidential client for a SPA, and you sometimes must, because for several services that want to make sure that it's really the business partner they want to talk to, they will issue you credentials, and you need to use that credentials to authenticate yourself. But don't get me wrong, I'm not saying that you should spread the secret to all the app instances that run in the different browsers. What you typically need to do, you need to think beyond the front end. You must see the SPA and the native just as a front end of your application, and you will potentially need to move the OAuth client code to a backend component. Then you can also implement all sorts of services using native and SPA apps. And the OAuth authorization code grant type just got hardened through the OAuth security guideline. Daniel Fett gave a talk on that last year at LocoMocoSec, so I won't go into the details. Just as a small glimpse, you are now required to do exact redirect UI matching to prevent code leakage. There is a new addition that requires you to use Pixie as a temporary transaction-specific secret to make sure that the code that potentially leaks can't be injected on a different device. And in case your client is connected to different authorization servers, you need to implement so-called mix-up prevention, either by using different redirect URIs for the different ASs, or by utilizing the new issuer response parameter that's currently being discussed in the working group. Okay, that's the base level. So that's the first recommendation, authorization code for all kinds of clients, for all kinds of applications that require user interaction. Now let's assume the client that wants to use the contacts in the calendar application does not want to establish that connection over and over again for every session. I think that's a clear use case. So what about long-term connections? There are different options how you can implement such long-term connections. One is you can use long-living access tokens, and there are large service providers out there that utilize long-living access tokens for that use case. So you could issue an access token that is good for months or years, and the client could use that to interact with the contact service. The downside is that either the API won't recognize if the data in the access token, your privileges, change, or you have to implement a callback from the contact service to the AS for every service invocation to check the expiration and the expiration of the token and the privileges of the user. If you do not want that the access token in the end stalls and does no longer represent the privileges of the user, you could also run through a reauthorization over and over again and use short-living access tokens. Clearly, the user experience would be really bad. So you would need to send the user through the authorization process, this browser dance over and over again. That doesn't make sense. But there is a solution in OAuth 2, and it's called the refresh token. And I would like to emphasize refresh tokens because I personally think refresh tokens are the most underrated feature in the OAuth 2 universe. So how does the authorization code grant work in conjunction with refresh tokens? So the basic flow is the same. You've got the redirect, the user's being authenticated, authorizes the access, the redirect goes back, there's again a code, and the code is being sent to the authorization server. But then the authorization server, beside the initial access token, also issues a refresh token. And this refresh token will be used in a subsequent process, because now the application has an access token, all is fine, is ready and set, and it can access the contact service. But what if the access token expired? So for example, I would say a typical lifetime for short-living access token is between 5 and 20 minutes. So after 20 minutes, the access token expires. The resource server will react with an HTTP status code 401. But instead of redirecting the user again to the AS, the client now uses the refresh token when the user requests a service to obtain a new access token. And it can do so in a backend interaction. So it just sends the post request, and instead of an authorization code, adds the refresh token as a parameter. And the AS responds with an access token. And as you see in the diagram, it can also issue a new refresh token. I will come back to that on the next slide. So that's an optional feature. But now the client has a new access token and can use this access token. So that's a much better user experience. And it's also much more secure. So my recommendation is use refresh tokens in combination with short-living access tokens. This results in a better user experience than frequent reauthorization of the access to a resource. And it also results in a much better performance, because due to the fact that you can use short-living access token, you can put all the data that you need to authorize API access in that token, and you do not need to call back to the AS. And it's also much, much easier to implement token revocation, because you just revoke the refresh token. And since the refresh token is maintained by the AS and is used by the AS, if the refresh token is deleted, the AS knows, no problem at all, simple design. If you want to revoke access tokens, you have to let know all the resource servers that accept a certain access token, that the access token was expired. So you have to communicate that in your whole deployment. Just killing a refresh token is simple. And if you have a short-living access token, that means once you have deleted the refresh token, you have a short time window, potentially 5 minutes, and after that minute, your grant is gone. So at Deutsche Telekom, that was sufficient for all of our APIs, was a simple design, simple to maintain, very scalable. If you need more, there are other designs. To prevent, the refresh token itself is now a very attractive target. And in order to protect the refresh token, you either use the fact that it is bound to a certain client and use the client authentication towards the token endpoint to prevent replay. Or in case of a public client, you can associate the refresh token with a certificate. And the public client, for every refresh, needs to prove that it controls the private key corresponding to that certificate. Or if you do not have that capability, you can rotate refresh tokens. And that's the reason why the token response also allows the AS to issue a new refresh token for every new issued access token. So that ultimately means the refresh token that you send to the AS is revoked. So it's one-time use. And you have to use the new refresh token for the next refresh. This in turn allows the AS, because it keeps track of those refresh tokens on the grant, if there is an expired refresh token being sent to the token endpoint, to detect something is going wrong. Someone most likely has stolen the refresh token and tries to replay it, and it can kill the whole grant. A further nice feature of refresh tokens is can be leveraged if you implement OAuth and APIs in a multi-service environment, because you can associate the refresh token with a combined grant that, for example, gives access not only to the contact service, but also to a cloud service. And you can do that in a simple, in one authorization process. And then you take the refresh token as a handle and ask the AS to mint access tokens for the different APIs. So you do not need to use a single access token, to invoke all those APIs, but you can mint audience-restricted access tokens, which is another nice security feature. So what's my recommendation for access tokens? My recommendation for access token, and that's the third essential, is use JWT-based access tokens. JWT stands for JSON Web Tokens, and that's an IETF standard for the representation of claims, of signed and potentially encrypted claims for certain purposes. In the context of OAuth, you can use that to implement access tokens. You see an example of a JOT on the right-hand side, and you see it contains several user data. The nice thing with JOT-based access tokens is, since they contain all the data that you need to authorize access to a certain API, so there is no need to call back to the AS. It's incredibly fast, and it scales very well because you don't need a cache, you don't need a callback with the AS. It's just a matter of checking the signature in memory, obtaining the data from the JOT, and applying your access control policy. And there is one draft I recommend you to read, which is JSON Web Token Profile for OAuth Access Tokens. It describes the different claims that can be contained in an access token and how they can be used and so on. So it's definitely a recommended read. So there might be use cases where JOTs are not sufficient, but in my experience, those are not the general case. Those are more the exceptional cases, such as you wanted instant revocation of access tokens. So for example, in the payment space or in the electronic signing space. But for most use cases, JOTs, short-living in combination with refresh tokens are the best way to go. Fourth recommendation, if you already have all the essentials implemented that I just illustrated, and you happen to have also clients that act on itself. So for example, a batch process that interacts with your API, you should use client credentials to issue. Well, the client credential grant type is pretty similar to the refresh token grant type. You've got a post request in the backend. You send the credentials, the client credentials, to the AS, and it directly creates an access token for this particular client. You typically have set up a policy for that client with the AS in that case. And then you use that access token to invoke the API. You might ask yourself, why don't I just use a certificate, authenticate with the API on being done? It's a very good question. And the answer is, access tokens allow you a very dynamic and fine-grained permission management because you have that central place, the AS, that stores all the policies, all the profiles, so you can very easily change the permissions of your clients in the same way as you can do for your users. And you just issue new access tokens and use them for API access, and you can make them audience restricted. And if you would use your certificates for authentication only, access tokens give you the advantage that they perform much better than having a data gap in order to determine the permissions of your actual client. So that's my experience. We use that for the philosophy at yes.com. We've got a couple of microservices that manage the parties in our ecosystem, and we have clients that act on themselves, and we have also clients that act on behalf of the users. And the nice thing is that if they all use access tokens and you normalize the content of your access token, you can use the same API for all those different use cases. And that's really powerful. What I always would recommend is to use certificates for client authentication. And now I'm coming to the fifth recommendation in my list of essentials. And this is server metadata. That's a rather small but very beneficial draft. What it allows the client to do is, instead of configuring all the different endpoints that are used in the OAuth flow. You've got one URL, which is the so-called issue URL that identifies an OAuth authorization server. It's shown in the yellow box in the right upper corner on the slide. And you can use that URL at well-known OAuth authorization server and then can obtain automatically the endpoints, the scopes, and other metadata. And most libraries these days allow you to just throw in the issue URL and they automatically configure itself. And that's very efficient. It also allows the service provider to change the endpoints without any impact on the clients. And it's more secure than a manual configuration because there is a strong relationship between the issue URL and the data that are being downloaded and so on. So you completely remove the threat angle that someone sends you via email a certain endpoint. Please use that as an authorization endpoint, and bang, you help to set up a phishing site, right? So that's why server metadata, from my perspective, is the last item on my essential list. So let me conclude. From my perspective, my personal OAuth 2 essentials are the authorization code grant type. That's the grant type to go for every application that requires user interaction. It's very versatile, it's secure, and it has gotten more secure with the latest update in the OAuth security BCP and with the upcoming OAuth 2.1. Combine authorization code grant type with refresh token because it gives you the best user experience in combination with high performance and security. If you want to have a universal API for all kinds of use cases, use the client credential grant type to authorize access for your service-to-service interaction. And as you see on the right-hand side, the first three elements, the essentials, are also part of the OAuth 2.1 feature set. The fourth element on the list are JOT-based access tokens. So refresh tokens in combination with short-living JOT-based access tokens give you the best performance and are standards-based. So there are libraries out there, and you could combine resources and authorization service from different places in your deployment much easier if you use that instead of proprietary token formats, for example. And recommendation 5, use server metadata because that's really very effective, very secure to configure your clients. And beyond those essentials, I would point out to you further modules from the OAuth ecosystem that proved useful in the last couple of years in implementing open banking and other more higher level security systems using APIs and OAuth. First of all, it's mutual TLS for OAuth. Mutual TLS for OAuth allows you to use X509 certificates to authenticate your OAuth client. And it also allows to associate the access tokens and the refresh tokens issued by the authorization server with the certificate. And this is a very powerful mechanism based on public key cryptography, with much better security properties than client secret. I would like to point out and emphasize that mutual TLS can be used with self-certain certificate. So there is not necessarily the typical pain associated with access X509 certificate and trust chains. So you can use self-signed certificates, and for example, that's a good idea if you have public clients that want to sender contains the refresh tokens. And that is really easy to use for a client developer. Just plug in the certificate and the key in your HTTP stack and you're done. It's a bit more challenging for the server side because in some of the deployments, especially cloud deployments, setting up mutual TLS can cause some headache, but it's possible. If you want to talk about that, you might also reach out to me. We use that on a daily basis in our ecosystem. And there are 2 more modules that are emerging in the last 2 years. One is pushed authorization requests. And pushed authorization requests is a quite simple extension that allows the client, instead of sending all the authorization request parameters through the browser, it allows the client to send those request parameters directly to the AS on a back channel, on a backend connection via post request, and it gets an identifier and just sends that identifier through the browser. And this has a huge impact because it allows to transport large authorization payloads, which is especially important in scenarios where you need to have fine-grained authorization due to regulation, for example. And it improves the security because the client can be authenticated before the user interaction starts, and all the authorization request parameters are integrity protected and confidentiality protected. But the request syntax, the payload, looks the same as for the authorization request. So it's really simple to change the request for existing clients. Rich authorization request gives you the ability to express rich, complex authorization requests. So for example, you want to do a payment and you want the user to authorize the amount, the currency, and the recipient. So that's an extension to OAuth that somehow complements or extends or replaces the scope parameter with a JSON-based representation. And last but not least, there is the FAPI2 security profile. And this is a selection that is being maintained by the Financial Grade API Working Group at the OpenID Foundation. It's a security profile for higher security APIs, and it's just being enhanced to its second edition, which also includes the before mentioned modules. And with that, I came to the end of my presentation, and I don't know whether there is time for questions.
There's absolutely time for questions. There's absolutely time for questions. Thank you very much, Dr. Torsten, and we're so glad that we were able to get you on for this. So let's go ahead and jump into some Q&A. The first one here is the refresh token being intercepted seems to allow a session hijack. How is this not just moving the auth secret to another target to be stolen?
Yeah, good question. Excellent question. I mean, the refresh token is definitely an attractive target. First of all, the refresh token is always exchanged in the backend via a TLS protected connection. So the attacker must be much stronger than, for example, stealing the code. As I said, the refresh token should be protected by authenticating or using sender constraining this refresh token. So yeah, you need to protect that, but the refresh token itself, by construction, is better protected than other parameters or elements of the OAuth flow.
Okay. Next question. Another way to issue new access tokens could leverage a session between an UA and AS. This could also be done transparently for the user. Would you consider that to be a reasonable strategy?
I'm assuming you're referring to the fact that you use an existing session and, for example, use iframe or something like that to refresh your access tokens. Yeah, that's possible. You could also use post messages. The problem with that technique is that the browser's cookie policy, the third-party cookies policy these days typically interfere with that pattern. That's why we have seen a move towards other solutions for that. And refresh token is a viable solution because it is not affected by the third-party cookie policy of the browser.
Okay. Next question. Regarding JSON Web Tokens based access tokens, any best practices for limiting the risk, especially the impact of leaking the private key and allowing an attacker generating their own JSON Web Token?
Well, we're talking about the private key of the AS. I mean, if you really take security serious, put your private keys in an HSM, right, or in a vault. I mean, that's the best way.
Okay. And then last question for you, at least I believe right now, unless any more come in. Do any production quality libraries implement RFC 8705 yet? Do you have any references?
Oh, help me. What's that? I don't know any RFC numbers under my mind.
Oh, okay.
What's that feature?
I don't have that one yet. So maybe we add that one take to the developers.
Can you say that? Can you give me the number again?
Yeah, RFC 8705.
Oh yeah, sure. Nimbus library, for example, implements that. There are a lot of libraries out there that implement MTLS for OAuth. So you might also reach out to me via Twitter or LinkedIn, and we can talk about that.
Okay, absolutely. Well, thank you very much, Dr. Torsten. I'm so glad that we were able to have you here with the Locomoco squad. And as with everyone else, aloha, and hope to see you again in the future. Take care.
Goodbye. Thank you very much.